So let's consider some real-life problems. Deviation IQ scores, sometimes called Welsher IQ scores, are scores with a mean of 100 and a standard deviation of 15. What percentage of the general population have IQs lower than 92? I see the word percentage. And I remember, oh, that's right, probability, percentage of the curve, percentile. Those all mean the same thing. And where do they come from? The suspense is building. Z-scores. The formula, x minus mu divided by the standard deviation. So what have we got here? X. I'm looking for scores that are lower than 92. So 92 goes in for x. The next thing I need is mu. Mu is the mean of 100. The standard deviation is 15. So pull out your rusty trusty calculators. There's mine. 92 minus 100 equals negative 8 on the top divided by 15 on the bottom. Ooh, it's a decimal! Don't panic. Negative 0.53. Remember, we only get 2 decimal places in a z-score. Negative 0.53. What does that look like? In my lovely table to the left, there's the mean. 1 standard deviation, 2 standard deviations, 3 standard deviations, negative 1, negative 2, negative 3. Negative 0.53 would be about a half a standard deviation lower than the mean, right here. I'm looking for the percentage or the area, percentage of the area, probability, percentile of the population that are less than 92. So we go find the probability given the z-score. Negative 0.53. There's negative 0.5. There's the 3. Looks like about 29%, 0.2981 have that characteristic. The percentage, the probability, 0.2981. Here's a problem that's almost identical, except we're looking for values that are 130. The problem is still asking for a percentage. How do you get a percentage? Yes, my friends, a z-score. And the formula is still the same. So, what's x? We just found that. It's 130. That's the value we want to know about. The mean is still 100. Divided by the standard deviation, which is still 15. (130) minus 100 divided by 15. Minus 100 equals divided by 15 equals 2. We can do that. I'm looking for a z-score of 2. So go find that on the chart. And that'll tell us the probability. The z-score is 2. 2.0. 0.9772. So when I have my mean, 1 standard deviation, 2 standard deviations, my z-score of 2.00 is at 0.9772. So the area behind is what my chart gives me, and that would be, if my z-score is 2.00, when I grow up I'll learn how to draw straight lines. Thank goodness for an undo button. 0.9772. So on my lovely graph, 0.9772 is the portion to the left. We're looking for numbers that are larger than this. So we're going to have to do the numbers to the right. So you say to yourself, self, if that to the blue arrow to the left is 0.9772, then that which is to the right would be the remainder of 9772. Whoa, where did I go? 1 minus 0.9772 equals 0.0228. That is the percentage of the general population that have scores larger than 130. Just to put that in perspective, 140 and above is considered a genius. So 2% is considered pretty close to that. So let's look at a different kind of problem. In a recent year, the ACT scores for high school students with a 3.5 to 4.0 GPA were normally distributed, bell curve, with a mean of 24.2 and a standard deviation of 4.2. A student who took the ACT during this time is selected. A student. Find the probability that the student's ACT score is less than 20. Looks like we're going for another probability, which means we're looking for another, come on, say it with me, z-score. And here's our formula. Let's go get the pieces. First piece, what is the number we're looking for? Numbers that are less than 20. What is our mean? 24.2. What is our standard deviation? 4.2. I don't know about you, but I'm not doing this one in my head. It's calculator time! 20 minus 24.2 and, ooh, that's interesting, divided by 4.2, negative 1. I can do that. The z that I'm looking for is negative 1. Negative 1 sits right about there. Z equals negative 1. I'm looking for everything that is less than negative 1. So what probability do I get from negative 1? Negative 1.0. My z-score is negative 1 gives me a probability of 0.1587. We're done. Let's do another one. Except we're looking for scores that are greater In a recent year, the ACT scores, ooh, it's the same problem, but we're looking for numbers that are greater than 31. Are we still checking for a probability? Yes. We want a probability? Yes. What do we need? Z-score. I know it's getting old, but work with me here. I'm having a good time. X is what we want, 31. The mean was 24.2. Our standard deviation was 4.2. What is the z-score? 31 minus 24.2 equals, divided by 4.2 equals, 2 decimal places, 1.62. What does that look like? There's my mean. 1 standard deviation, 2 standard deviations, 3 standard deviations. I'm only looking above the mean because it's positive. 1.62 happens to sit right about there. But remember it said greater than, so I'm going this way from a probability that I want. Unfortunately, the chart is only going to give me this way, and I'll have to subtract. So let's go to the chart. .62 .9474. Again, remember, 0.9474 is this portion of the curve over here, not necessarily the portion that I want. I'll have to subtract from 1 to get the portion that I want. So what's the probability of getting a z-score that's bigger than 31? Well, for those of you who have taken the ACT, you know those odds are pretty small. In fact, they're just about 5%, 0.0526. So 5% of the population gets a score better than 31. I hope it was you. Now let's do a between problem. Why? Because we can. We're looking for scores on the same ACT thing that are between 25 and 32. So I'm going to have to find 2 z-scores. So I'm going to have to make things a little bit smaller here. I can do that. I need 2 z-scores. We'll call them z-score 1 and z-score 2. For my first z-score, I'm still using the formula x minus mu divided by the standard deviation. The first one will be for the 25. 25 minus the mean of 24.2. That is a 4. It just didn't look like it. 24.2 divided by 4.2. That's a 4 also. It just doesn't look like it. What will the z-score be? 25 minus 24.2 divided by 4.2. 0.19. What's the z-score? 0.19. What's the probability? 0.19. .5753 is the probability that goes with 0.19. Here's one standard deviation, here's two standard deviations. 0.19 would be around here somewhere. And it's saying, with a probability of 0.5753, that about 57% of the curve is behind it. But that's not what I want. I want things that are between 32 and 25. Score, because I'm not looking for area to the left of z equals 0.19, I'm looking for areas that are between these two numbers. These two numbers have to be converted to a z-score. First one has been, the second one shall be right now, using the same formula. 32 minus the mean divided by the standard deviation. That also is a 4. That z-score converts 24.2 divided by 4.2. That is a z-score of 1.86 to the nearest hundredth or second decimal. 1.86 is over here somewhere. The probability that I'm going to get for this answer is going to give me everything behind. So in essence, what I'm going to have to do is subtract out the purple. Get rid of it. That will give me what I want, which is right in between here. Red minus purple equals black. Something you didn't know that you now know. 1.86 has a probability. What is it? 1.86. A little hard to read, but I'm trying to color code here. 0.9686. So I'm looking for red minus the purple to give me what I want, which is shaded in between in black. If you see the words between, you need to subtract. Subtract probabilities, not z-scores. The answer that I'm looking for, 0.3933. To answer the question, about 39% score between 25 and 32 on the ACT.